Today, we're going to take a look at the Zesty Nimble. Cool name, right? The Nimble is a remote direct drive extruder. They use a cable to connect the extruder motor to a feeder that sits on top of your hot end carriage. This gives you the best of both worlds when it comes to direct drive extruders versus Bowden setups. You get all the positive of the direct drive extruder with the flexibility and the lightweight hot end carriage of the Bowden. So for example, like on this Creality setup, you have a feeder that sits on top of your hot end carriage. It does require a special mount for whichever printer you'd like to put it on, but you feed your filament in here, and then this whole mechanism is driven by a cable with your stock extruder motor with an added mount to hold the cable and this coupler to tie it all together. Now this Nimble setup was sent to me by one of our community members. Corinne, thank you very much for sending this over. It has been a lot of fun to test with. Now there are a couple different models of the Nimble, including a new V2 version that's coming out in a couple of months. This is the V1 version. They're available in a couple of different lengths, a 75cm version, a 95cm version, which is this one, and a 120cm version. Now, Zesty does recommend that you use the 75cm version on the Ender 3. My guess is the shorter the better, but the 95cm version gives you a little more versatility if you wanted to install it on something like a CR10. So there are a couple of steps to getting this set up and working correctly, but let's start with the hardware portion, get it set up, and extruding some filament. So the first thing you need to figure out when you're going to install the Nimble is you have to figure out what kind of mount you need to use it. Now on the Creality machines, the CR10, the Ender 2, the Ender 3, they have something that looks like this. This is just going to set on top of the hot end carriage, and then you're going to use this in place of your Bowden coupler. This will screw into the top of the hot end, and then you have a short piece of PTFE tube that'll go in there as your liner, and the Nimble will sit on top of this part. It sets in here just like this. Now there's a lot of different mounts for a bunch of different printers that Zesty has created for the Nimble. And you can 3D print these, but it's a pretty difficult print. This is out of PLA, and you can see the underneath, there's a lot of supports needed to get all this to come out right. Again, it can be done with an FDM printer, but maybe not the best solution. But they also offer these. These mounts you can get from Shapeways. These are SLS printed, and they are great looking parts. They really are. The worst part is this part cost me $25 from Shapeways. It's $20 plus $5 shipping. And that's not all that attractive after you've already paid for the Nimble, and then you have to buy a few more parts. But they are there if you need them. So I have tested the PLA part. It works okay, but for this tutorial, we're just going to go ahead and use the SLS part because I already purchased one. So I'm going to use two M3 by 30mm screws to mount the Nimble on top of the hot end piece right here. And this piece will get two 3mm nuts pressed into the back. It should look like that. Now onto the printer. First, I'm going to remove the Bowden tube. I've got a zip tie here. I'm just going to cut that off. We'll take the tube out. Then we'll take the coupler off. You can use a 10mm wrench. And then we can go ahead and slide the mount on. We shouldn't have to remove this carriage. We can just slide it in from the side. But there is one tip that I can give you. If you don't have your wires managed where you have some sort of covering all the way down to inside here, go ahead and try to push this up and zip tie it so that you do. If these are all grouped together and managed like this, it's way easier to put the mount on. So the mount has a spot where the wires go right here. If those are all collected, this is way easier to do. So put the mount on kind of to the right of the hot end carriage, push down a little bit, and then slide it to the left. There's a lip on the bottom of the mount that actually slides onto this metal cover, and then there's two tabs over here that will kind of snap in as it goes into the cover hole. It's a pretty good fit. And then the threaded piece will go in this hole right here. It screws into the stock hot end. This is designed so it fits a 4mm hex wrench. It doesn't need to be super tight, just get it snug. We can go ahead and remove our Bowden tube from the other end. We're not going to need this anymore. We're actually going to be a remote direct drive printer from now on. And you'll also need some PTFE tube to serve as your liner for your hot end. Because the Creality hot ends, that tube goes all the way down to the nozzle. So I recommend you take a piece of PTFE tube and use some sort of cutter to get the end of it as flush as possible. This is kind of important on these Creality machines. This cutter's from Capricorn, but I'm just going to snip the end of this off. And then for the Ender 3, it's probably the same on the CR10 and a couple of the other Creality machines. I recommend using 55 millimeters of this tube for your liner. That's going to let the tube stick out just a bit on the top of your mount for your Nimble. And then the Nimble will apply pressure to the tube so that it doesn't move up and down. You don't want it to move around while it's retracting because that's going to cause jams near the nozzle. So here's our 55 millimeter piece. We can just slide it down in here like this, but we do want to preheat the hot end. And with the hot end preheated, we'll just go ahead and force the tube down inside. This way it's going to force out any filament that might be in between the tube and the nozzle. You definitely don't want any gaps down there. And you should have about 2 millimeters of tube sticking out of the mount on the top here. That's just enough so the Nimble will press down on it so it doesn't move around. Now we can go ahead and let the hot end cool down. And before we install the Nimble, I thought I'd go ahead and show you how it fits together and what's inside it. So you have two covers, a top and bottom, but these are identical, so you can install it either way. But that depends on what printer you're going to put it on. On the Creality machine, this side is going to be the bottom portion, because it'll mount just like this. On both sides, top and bottom, you have a bearing that slides in. And that bearing supports the worm gear that actually drives the cable. There's a square hole on the worm gear on both sides for the cable to slide into. And then you have the horizontal portion that gets driven to drive the hob gear. It just sets in here, right like that. And then the other piece goes right on top. And again, this can go either direction, but for the Creality printer, your idler arm here just slides in and clips up like that. Your filament gets fed right there. Then you have the mount for the motor side, the coupler that couples the motor shaft onto that cable, and the cable cover. And then inside that cover, you have this round wound steel cable with square ends, so you can use the set screws on the coupler to attach it to the motor, and it'll slide down in the top of this feeder in the square hole on the vertical gear. So I prefer to actually attach the cable to the feeder before I put the cover on, so I'm 100% sure that it's in there as far as it'll go. Right like that. Then you can slide your cover on, like so, and then this cap will just twist lock into place. And now we're ready to install it on the printer. So the Nimble is set on top of the mount just like this. Remember, it's going to keep that tube from sliding out. Again, I'm going to use M3 by 30 millimeter screws, one here, and then one on the back over here by the cable connector. These two don't need to be crazy tight, just snug enough. And then we can move to the back and work on the extruder motor mount. Now to the back side of the printer where the extruder motor is, I have the EZR extruder, but it's going to be pretty similar to the stock extruder. I'm just going to take these screws out and pull the motor off. The extruder actually has screws that run through it that hold the motor onto this metal plate. Screws are out, I'll just pull the motor out. We can lift the extruder off. The motor, we can remove the extruder gear. And then we're ready to mount our Nimble. Motor side of the Nimble, you have this housing, and then you've got your square shaft end that's going to turn the extruder. You also have this coupler that mates up the motor to that shaft. So on the shaft side, you want the end of the coupler that has the 4 set screws. And we're just going to slide it on right now. We're not going to tighten it up quite yet. But you do want the set screws on the flat sides of the shaft. We'll just set it on there like that. And I'm going to put my mount with the back of it facing towards the back of the printer. There are several different holes in here so that you can mount it on extrusion or whatever printer you might have. But on the Creality machines, it actually just sandwiches on the existing plate with the motor. So screws are going to go down through this mount and they're going to thread into the motor. I'm going to use M3 by 8 millimeter screws, 4 of them. I'm going to try to get you a better shot of this from the side here, but the flat part of this motor shaft will just slide into the coupler, the flat side facing the set screws, just like that. Then we can go ahead and put our motor mount screws in. The motor's on, now we can go ahead and tighten up the coupler. Just make sure the 4 set screws at the top here are on the flat sides of that drive cable. Just kind of get it balanced how much you have on the motor shaft versus the drive cable, but make sure you get all 4 set screws on the flat parts on the drive cable. Make sure it spins freely, and we should be all set. So that's pretty much all there is to it for the hardware portion, but there are some firmware changes you need to make, because the Nimble has a different gear ratio, and it's going to spin a lot faster than the stock extruder would. And there's a couple ways to change this. One, you can do it in the firmware, or we could just make those changes in the Start G-code. And if you've never flashed Marlin onto your printer, probably the Start G-code is going to be the easiest way to go. But before we get that set up, let's go ahead and plug it in. We'll use Pronterface to make some test movements so I can show you what it's going to do when you install it. So I'm plugged in USB to the computer and I connected up via Pronterface. If you don't have Pronterface, there will be a link in the description. Let's just do an M503 to take a look at what's in the configuration right now. You can see right here, this M92 command, our E steps are currently set to 93. So I'm just going to give you some side by side here to show you what it does when we do some movements. I put a mark on it right here so you can see it turn easy. Remember, prevent cold extrusion. You will have to heat the hot end up before you can turn the extruder. So we'll just take that to 215. Now that we're up to temp, if we hit extrude, you'll notice that's turning really slowly. Because of the way that the Nimble is configured, the gear ratio is somewhere around 30:1. So that E step of 93 is way too low. Now, depending on what printer you have, this might be an issue. If you've already flashed Marlin or you have a Marlin configuration for your printer, you can just change it in Marlin and then upload it to your printer. Here's an example of a Marlin configuration. Default axis steps per unit, you would just change this number right here to 2700. 2700 is what Zesty recommends you start with when you're installing your Nimble. You will need to go back and do a filament tune because every filament is going to be just a little bit different, and then you can adjust this number up or down depending on how much filament you extrude for a certain amount of steps. Back to Pronterface. So that's all fine and good if you have a copy of your firmware, but if you don't, you can save these values in EEPROM. I have a Creality 1.1.5 board, and it does have EEPROM enabled so you can save things in it. So we did the M503 to see what's in EEPROM. We can make a change to our E steps with an M92, E2700. We can go ahead and display that change again with an M503. We see it's 2700 right here. And then if EEPROM is enabled, you can save that with an M500. Now, if you have an older Creality board or some other boards that don't have EEPROM enabled, you won't be able to save your settings like this. You might be able to save them one time through command line, but they won't save throughout reboots. So your other option to configure this is to run some commands in your start G-code, so it makes these settings each time you start a print. So if we head into Prusa Slicer and we go to Print Settings, we can enter those commands in custom G-code right here in the Start G-code. That way it's going to run those commands every time you start a print. And these are the recommended settings by Zesty for the Nimble. We have an M92 command that sets your extrusion to 2700. We have an M201 that sets your extruder acceleration to 120. An M204 that sets your retraction acceleration to 120. An M205 that sets your jerk to 3, and an M203 that sets your max feed rate for your extruder to 45. If you're unsure on how to alter your firmware or set things in EEPROM, I recommend you just paste all these commands in your Start G-code so that every time you start a print, it will be configured correctly for your Nimble. So we can save this for now, but let's head back into Pronterface. And now that we have our E steps set to 2700, let's take a look at that extrude command one more time. We'll hit extrude. You can see that it's turning it much faster now. Those are the recommended settings from Zesty when you initially configure your Nimble. But as with a lot of things, there's going to be some tweaking involved. And another setting you need to look out for is the reference voltage of your extruder motor. You're going to have to adjust this down because of the way the Zesty works. You're going to have to find a balance in between that reference voltage, ultimately the torque that the extruder motor has, and the acceleration and speed of the retractions that you do. Because of the way the Zesty is set up at the 30:1 gear ratio, and you're turning the extruder motor at a high rate of speed, if you do it with too much torque, it's going to cause that motor to skip. And let me show you what that looks like, and we'll go over some of these settings real quick. Now, if you pay attention to the coupler over here, again, I do have that line drawn on it. I have the stepper driver set to 200 millivolts, and the retraction and acceleration setting for the extruder are set to 40. Again, there's going to have to be a balance here. You can lower the voltage and up the acceleration, or the other way around. But let me show you what it's going to do if your reference voltage on your stepper driver is too high. Now, this is at 580 millivolts. If you watch the coupler again, when it starts doing the retraction, you can see when it tries to feed backwards, it's actually skipping steps. You can probably hear it as well. It's grinding the motor. This same impact is going to be seen if your retraction settings are set too high for your acceleration or your feed rate. And depending on the stepper driver that you have, your driver might just stop altogether. I know these 2208s will do that if this gets too bad. If you saw my video for the 1.5 silent mainboard install on this Ender 3, I had some questions on how Marlin was configured to handle the 2208 stepper drivers that were on this board. If you look in the M503 command, you have an M906 that should allow you to adjust the current for those drivers. But that isn't the case. So it looks to be that the firmware is configured for the UART mode of the 2208, but the board is actually configured for them to be in the standalone mode. And the big difference would be you'd have to adjust the reference voltage with the potentiometer on the board. That took me a minute to figure out, but once I did, it was pretty easy to adjust the voltage. I'll show you how to do that now. Since these drivers look to be in standalone mode, we can just adjust the potentiometer to adjust the reference voltage. We'll put our negative lead on the negative input to the board back here, and the positive lead to the center of the potentiometer for the extruder motor. We're setting at 523 right now. I've found that 200 millivolts works best for this board with the Nimble installed. So we'll just turn that potentiometer down a bit. I've got my ceramic screwdriver. We'll adjust it. We'll check it again. We're setting at 216, 217. That should be good. So finding that balance in between the torque needed for the extruder motor and the settings in the firmware took a little bit to figure out, but once I did, everything seemed to start working well. So let me go back and show you what my settings currently are versus the settings that Zesty gives you for the default. So back to Prusa Slicer, these are the defaults from Zesty, but I did adjust these quite a bit for my printer setup. Again, I am running at 200 millivolts for the reference voltage on the extruder stepper driver. I set my extruder acceleration to 40, my retract acceleration to 40. My jerk setting, I took it all the way down to 0.1. That shouldn't affect your print speed that much. And the maximum feed rate for the extruder, I left it at 45. And as far as retraction settings for the extruder goes, we can jump over to extruder 1. I'm at a length of 1. You can actually probably go just a bit higher than that, maybe 1.2. And the retraction speed, I set it to 30. And that gets it printing pretty well. Also, don't forget we still need to tune the extruder's E-steps. That default 2700 is just a starting value, but we need to go through and actually tune those. I'll show you how to do that. So get your ruler and find a good flat spot to put it so it's the same every time. Right on top of your Nimble there is a good spot. And let's just mark it at 100 millimeters. And then we'll preheat, and then we'll just go in and move the extruder 50 millimeters. So let's go into Prepare, move Axes, Extruder. We'll move 10 millimeters at a time, and we'll just add 50 to that number. We're at 35. We'll take it to 85. And after we've extruded our 50 millimeters, we'll check it again on the ruler, and we're setting pretty much right at 50 millimeters. So I have mine currently set at 2650, so that looks to be pretty close. If you didn't extrude enough, raise the number. If you extruded too much, lower the number, and there's a math problem down here below to help you figure that out. So now that we know what our E-step setting should be, we can set that right here in the slicer. M92, E, 2650. And now every time you slice a model, everything will be automatically adjusted for this printer to use the Nimble. Now everything is set up and configured to start using the Nimble on this printer, and it's finally time to start doing some test prints. And while I was testing the stock extruder versus the Nimble, the prints came out pretty close to the same. This is a stock Ender 3 benchy using my standard profile. Retraction length is 6 millimeters at 25 millimeters a second. This benchy finished in 1 hour and 55 minutes. This is my stock slicing profile on the Nimble. The only changes that were made were the ones configured for the Nimble and the retraction settings. 1 millimeter of length at 30 millimeters a second. This one finished in 1 hour and 56 minutes. So side-by-side print quality with and without the Nimble, it's pretty much the same. Also, we didn't get any speed advantage here because of the settings that I had to make to get the Nimble to operate correctly. But that's not saying now that it is set up properly, you couldn't go back and up some of the feed rates to try to get a little more speed out of it. But there is one more configuration of the Nimble that I wanted to show you before the end of this video. And that's the Sidewinder version. They actually make a version of the Nimble that you can lay on its side while it's on the hot end carriage, so you can feed that cable in from left or right. This just gives you even more options for a direct remote drive extruder like the Nimble versus a Bowden tube setup. So should you go out and buy a Zesty Nimble for your 3D printer? Well, if you're using a standard Cartesian i3 style machine, there's probably not going to be a lot of advantages installing the Nimble. But if you have a high-speed 3D printer, like a Delta or a Core XY machine, where you're feeding the hot end carriage through a longer Bowden tube, essentially you could install the Nimble and convert that to a direct drive system and still save a lot of the weight on the hot end carriage. And that's where the Nimble is going to shine. At that point, you could even go as far to print flexible filament that you never would have even dreamed of on that Bowden system. And that could be really cool. Hopefully you found this video helpful. If you did, please consider giving it a thumbs up or subscribing to my channel. If not, leave your thoughts in the comments below. And as always, thanks for watching.